As mentioned earlier, skew lines are lines on different parallel planes. So it's like if you draw a line on the floor of level 1, and then another friend draw a line on the floor of level 2, and because the floors are parallel, so the line need not be parallel, but the two lines will never intersect. So such pair of lines we call it skew lines. Let's look at more examples. In this example, you are asked to show that L1, L3 are skew lines. So you just need to equate the equation of L1 with L3. Yeah? So it's I plus T1 I 2J3K equal to 2I plus J, then T3 3I plus J. Yeah? And after that, you can compare the I component. It will be 1 plus T1 equal to 2 plus T3 3. Then you can compare the J component, K component. And from the K component, you already have T1 is 0. And let's try to solve the first two equations. If you try to solve the first two equations, you'll find that you give you T1 is 2 over 5. T1 is 2 over 5. And it's different from the third equation which tells you T1 is 0. So you have a contradiction. So with that you can say there's no solution to the three equations. So we conclude that L1, L3 do not intersect. And then you just need to check the direction vector of L1. Let's say you call it U, and of L3 you call it V. Yeah? These two they are not parallel because U and V not parallel. U, V not parallel, so they are skew lines. You have to remember when you look at intersection of lines, because you have I, J, K, 3 components, so which means you have three equations, but there are only two unknowns came from the parameter of L1 and L3. Yeah? So three equations, two unknowns. So you solve any two of them, you must satisfy the third equation, the answers. And since in this example, the T1 value you get from solving first two equations is different from the third equation. So that's why we can conclude that the equations has no solution. So L1, L3 are skew lines. If you solve the first two equations, the answer is same as the third equation, can satisfy the third equation, then the two lines will intersect.